I'm just kidding. You don't need to listen to one more repeat of that. Or, I mean, unless you want to. Oh, on screen? Are you sure you don't want to listen to this really nice music? Please hold. Please stay on the line. Your call is important to us. All operators are currently unavailable. Please stay on the line. No? No? You sure? Are you sure? I mean, I got another one. I got another one if you, I mean, here, look, ready? This song's a banger. It's straight fire. Oh, the Cisco hold music. Oh. Hit it with the xylophone. Oh. Yeah. All right, no, we can't listen to that for too long. What's up? What's up? Thanks, I hate it. What, you guys, all the people out there that work in IT, you don't love the Cisco hold music? Really? Oh. Oh, that's weird. That's what your name is Jeff.
My name is Jeff.
Yeah, you didn't know I could do that. Now you know. We also have bruh. And then we have
Discovery, go and throttle up.
that's a tier 310 month resub. $1.10. Nice. Please stop being Kai Cenat. Who the hell is that? I don't know who that is. I'm just kidding. I know who he is. You have my hat. My hat. Maybe. Oh no, he's had a sound. Oh, dude, I've had a melon farming soundboard this entire. That didn't bleep it. So, all right, maybe we should try it again. Me in the. You stupid piece of monkey. You play it where it lies.
Oh, this is space. I'm in space.
Ew. Hi, Hilky. Gifted 10 subs. Please use that on the Flame Trench. I don't think it would work with Flame Trench. I don't think it works. He's totally not yelling at me. Well, timeout time. This is why I follow. You freaking play it where it lies.
Discovery,
Frick you.
go and throttle up.
This your ball? It landed on my foot. No, Hokey did it for me, Graham. That's why we're good. Now watch this drive. All right. Shall we, Space News? Shall we? Let's shall. All right, cool. Let's start out here with that thing. News in space. I got that reference, Blitz. It's so ugly. Yeah. Another render that'll never be made down. So Intuitive Machines posted this right when we started up this morning. Shaping the future of U.S. space manufacturing. We've partnered with SpaceForge to provide expertise that informs the design of our Earth re-entry vehicle, enabling the precise return of semiconductors from orbit. So this thing is part of a big infrastructure that Intuitive Machines is looking to do with Space Forge about doing small sat launches that have it's like that with a service module attached to it. And the service module is a small factory that makes semiconductors. And then the manufactured semiconductors enter this jelly bean with a rocket engine on the back, and it comes back down, and they retrieve it. I don't really know how big that reentry vehicle is, per se, but it exists. I mean, now that's also to kind of say like whether I'm not entirely sure this thing would be able to be employed in scale. So unless there's something that really makes semiconductor manufacturing on orbit, like a really like a technology disrupting trend, I mean, I'm not really sure what you're going to get out of this, but I don't know. It's still cool, and it's a little mini reentry vehicle. Once again, I'm not really understanding how big this thing is. I would guess that if those thrusters are about like maybe the size of a golf ball, that this thing's like maybe the size of a golf cart. Swing and a miss. That was just a practice swing, chat. A lot of money for a technology demonstration. I mean, we have no word on cost, but once again, like, is it a tech demo? The space environment offers a unique set of environmental conditions that are hugely beneficial for certain processes that are complicated to perform in Earth's atmosphere under the effect of gravity. Costs and opportunities to take advantage of microgravity for manufacturing have been limited thus far. But this is all about to change with the Space Forge at the forefront of the next industrial revolution. We offer the opportunity to make space work for humanity. Yeah, okay, we've heard this before. Utilizing microgravity as a service with our world-first reusable, returnable orbital manufacturing platform, Forge Star. Lone Star. Spaceforge has developed a dedicated platform for your microgravity production, research, and experimentation needs. What makes us unique is that our proprietary return system will bring your precise cargo back to Earth gently with no shock on landing, safely delivering high-value products back to you in an innovative vehicle with a precision-engineered capture and recovery system. The original machine had a base plate of prefamulated amulite, surmounted by a malleable logarithmic casing in such a way that the two spurving bearings were... Oh, wait, no, that's something different. Sorry. I'm just going to read the copy. Electronics. Our current age of information was built on the massive leap forward that solid-state technology enabled. Integrated circuits and microchips touched almost every area of our modern lives and global economy. The next generation building blocks of the 21st century electronics will be made in space, where the advantages of being in orbit allow the development of supermaterials that are a magnitude more efficient and powerful than anything we've seen before. Strong words from a strong man, Captain Insano. Read the copy. It's good. Just read it. Medical breakthroughs are needed now more than ever. On-orbit R&D can accelerate new discoveries and improve the efficiency of existing drugs, from compounds with a vastly improved shelf life to pure protein crystallization that will enable better drug delivery methods. Off-world production in a new age of space will revolutionize pharmaceutical innovation on Earth. So you guys don't have any business yet. That's what you're trying to tell me. Yeah, you don't have any business yet. Okay, cool. You could have just said that. 10 launches a year annually. Low barrier for entry. Helvetica fonts. Okay, yeah, okay. You guys don't have any missions. All right, that's fair. That's fine. This is not... I'm not hating. That's a cool thing. That's cool. That's a good idea. To be honest, I think that's pretty neat. 10 is a high cadence. I mean, that's a lot of reentry vehicles to make, Grim. Are the reentry vehicles reusable? Because that's going to affect how your industry gets planned. Like, what's your industrial base look like? Are you going to tool up to build one of these every month and a half? You're going to have to do that if you want to hit 10 a year, right? Every 90 days, you got to build one of these. So actually less time than that because 10 launches, right? So it's going to, this thing must be small, must not be big. I don't know how big the vehicle is. They really didn't give any dimensions. I'm guessing it's small. It might be this big, dude. But either way, they said reusable, I think. Hey, Yuri, what's up? Okay, cool. Isn't there multiple tech tree points that need to be unlocked? ISOU material processing before thinking about high-tech manufacturing? Why would ISOU need to be developed for doing stuff on orbit? The NASA article. NASA has the benefits of semiconductor manufacturing in low Earth orbit for terrestrial use. Subject matter experts in semiconductor and in-space manufacturing collaborated on a white paper that outlines how microgravity benefits the production of semiconductor-related materials. Earth's gravitational forces pose substantial barriers to quick, high-yield semiconductor production. Microgravity offers a path to overcome these barriers. There are also substantial practical benefits to incorporating LEO-based manufacturing into the supply chain. The white paper argues that transitioning this industry into space is a path forward to achieving NASA's in-space production applications goals. These goals include strengthening the U.S. technological leadership, improving national security, creating high-quality jobs, providing benefits to humanity, and enabling the development of a robust economy. And moreover, when a fluorescent score motion is required, it can also be drawn and conjoined with a reciprocating dingle arm, which will reduce sinusoidal repleneration. No, that's cool. This is cool. On-orbit manufacturing is huge. And, you know, you're not going to build like a gigafactory in space initially. This is a good way to kind of get your feet wet. That's why I don't think it's necessarily bad. With that being said, though, bro, like, put some racing stripes on it or something, please. I don't know, Sad. I couldn't say. I haven't looked. I'm kind of scared to. Fine. Tried a space shuttle with methylox propulsion, landing reusable boosters in RSS RP-1 KSP. This turned out quite big with 6B4s on each. You have 2 new Glens on the side of a shuttle stack? Yikes. The first gigafactory in space will be on the moon. Bold statement, Cotton. Let's see if it pays off. It looks like a submarine. It kind of does, doesn't it? So we got a new video here. Brilliant Pebbles is back. What the hell is Brilliant Pebbles? What is that? Hold on. My phone charger cable is stuck in one of the chair wheels. Oh, I love it when that happens. Brilliant Pebbles was a space-based ballistic missile defense system proposed by Lowell Wood and Teller. All right, in 1987, near the end of the Cold War. What the funkin' waggles with? I've seen this before. Executive summary. Much of the current losses involved in silicon chip manufacturing, as high as 20%, is caused because of gravity and the difficulty of fighting it. Cool. Hmm. Bill, are you saying that this looks just like it? Or that this program is actually a thing? It looks just like it. Okay. I was gonna say this is a heck of a way of doing things. That is a vibe. Huh. That's weird. It wasn't lacking in ambition. Nuclear pumped X-ray lasers for ICBM defense. It's just a hit to kill interceptor as a small sat. Yeah. Okay. Andrew, a bit random, but maybe somebody knows the answer. Are the forces a submarine has to endure worse than a spaceship in the vacuum of space? Like, I keep hearing how submarines need to withstand crazy pressures, but how does that compare to space? No, you have it right, Andrew. Submarines have to deal with... Okay. You're dealing with compression forces with a submarine. Okay? In space, your spacecraft deals with what's called tensile forces. So what's the difference? Compression is pushing in. Tensile is pulling out, right? That's the difference. A submarine, okay, Andrew, you ever dove in a pool, like a pool with a deep end? You ever go down and touch the bottom of the deep end? What does your ears do? I'm asking, you can answer, it's fine. I'm waiting. I'm waiting. I'm waiting for you, bud. You wanted an answer. One can feel the pressure. That's just maybe 2 meters down. The further you go under the water, the more water you have on top pushing down on you from the force of gravity. Submarines have to be able to hold out an insane amount of pressure. They have very high pressure outside of the spacecraft and very comparatively low pressure inside of the spacecraft. You needn't go 2 meters down below water before the pressure really starts to change and your ears feel it, right? And what you do is you hold your nose and try to blow through it and your ears depress, which is nice. Feels great. It's a really, really nice feeling getting all the out of your head. But anyway, a spacecraft is the opposite. A spacecraft is in the vacuum of space. The vacuum is an inconsequential amount of pressure. It's basically nothing. It's not nothing, because there's still stuff up there. Space isn't completely empty, all right? If it was, it would be dark. There's light, there's stuff up there that is in the way, but it's not enough to make like 1 psi or 14.7 psi of pressure. Now, the ISS has just that on the inside. You have 1 atmosphere on the inside and basically 0 atmosphere on the outside. We're talking about a 1 bar difference in pressure. Okay. A submarine deals with, oh, I don't know, guys. What is it? What would you think? A submarine 300 feet down? Probably 300 times that pressure? Something like that? I don't know. I'd have to, I don't know. I don't do submarine stuff. I do spacecraft stuff. Now, the interesting thing here, Andrew, is that spacecrafts aren't as airtight as you might think. They're not. They're really not. They leak all the time. Every spacecraft leaks. Weird, huh? It's just a little bit. It's not obviously deflating like a balloon, but even the ISS leaks. Even before the thing cracked open, they had a crack in the hull. Don't worry, they fixed it with duct tape. You know, everything leaks to an extent, to a little bit, but it doesn't leak as bad as you might think. It's like how an airplane flying at 30,000 feet, that your hull is pressurized, but it's not it's not like airtight. You're still leaking, right? It's still leaking atmosphere. What keeps the cabin pressurized on an airplane nowadays is bleed air from the engines, because that's high pressure air that you're getting from the engine, sucking in all that stuff and going through the compressor, right? They leak. It happens. But, spacecraft don't have to be like super awesome, super strong like a submarine. They don't really need to be. The pressure differential here. You got to look at like the difference in pressure. In a spacecraft, you have 1 bar difference. A submarine needs like 300 bar difference or something crazy. I'm making up that number, but it's a lot. It's because you have pressure on the outside and not the inside. But it's about the change, the difference in pressure. Submarine has 1 bar inside the submarine because humans need to human, and like 300 outside. A spacecraft has 0 outside and 1 inside. It's not a lot of pressure differences, dude. It's not that big of a deal. Like I say that like, you just fly around in your spacecraft and it could be like Swiss cheese. No, it's obviously a big deal. You want to keep all that air in because you're not getting it back if it leaks. So it's not as risky as subs. I would say they're about equally as risky. Dude, I would say they're both equally as dangerous. Going underwater, going down a long distance underwater is dangerous. Submarines don't go to the bottom of the ocean. They can't go down there. The pressure will crush them. Only certain submarines can get like to the bottom of the Atlantic Ocean, the bottom of the Pacific Ocean, right? Submarinering is dangerous. It's about as dangerous as space flight, dude. But the thing is, we make a lot more submarines than we do spaceships. So submarines are perceived to be a lot safer. You don't really hear about people getting hurt on a submarine. In fact, the U.S. Navy has only had 2 problems with submarines ever. They only lost 2 subs, basically since 1945, the Thresher and the Scorpion, and that was for other reasons. So being a submariner doesn't seem as dangerous, right? But we make more submarines than we make spaceships, so I'd say they're equally as dangerous. Going down underwater, doing what a submarine does is no joke. That is very dangerous. Physics wants you to die when you're at that depth, even at the shallower depths that our submarines can go to, or anybody's submarine, Yeah, a submarine can only go down so far, Andrew, before the weight of the ocean above it will crush it like a soda can. I don't like bringing this up, but the Ocean Gate sub, that's like that. It's not great. I don't like talking about people's deaths on stream, but that's what I mean. You don't screw around with this stuff. Check the chart. Here is a chart. Is it a chart or is it a graph? Look at this graph! All right. Good question, though, man. All right, let me see. So at 1,000 meters, or about 3,300 feet, you're dealing with 1,000 atmosphere. Oh. Yeah, it wasn't 300. It was 1,000. Yeah, see, that's what I mean. Thank you for the chart, Aqualex. We learned something today. Yeah, that's 1,000 bar, fellas. Yeah, you die. Or decimal point, you know what I'm saying. That's still bad. 100, sorry, yeah, that's because PSI, yeah, you're right. It's 100. 100 is still death. Like, I'm not gonna lie to you. It's not 1,000. 1,000 is down here somewhere, but 100 is that's still a lot. Yeah, Andrew, humans. So like that's how deep the ocean is. Humans could, like, you'd be hard pressed being like right here. Like that would 200 meters would probably kill you. Like I mean, like what are the deep diver like those deep sea scuba divers? Like what do those guys do? I mean, even then, going down to 200 meters, even if that is possible, I know that that's difficult. That's not something you can just do. Like you really have to be careful. I'll quote Scott Manley here. At these energies, humans stop being biology and start being physics. Good way. 100 to 200 max. Yeah, there you go. What could a COPV take? A COPV would not take much, Peter. COPVs are designed to hold this much PSI, but once again, that's pushing out. That's having a high internal pressure and a low external pressure relative. A high external pressure in a COPV makes COPVs very angry. Yeah. Yeah, it probably, because once again, tensile forces versus compression forces. COPVs are designed for tensile strength. Sorry about the decimal point thing. I zigged when I should have zagged. Yeah, 100 bars, death. Yeah, that's not breathing. Is the trench behind you labeled? Woof. Correct, Octoplex, yes. Jeez. The Virginia-class submarine can only go to 490 meters. Yeah, dude, submarines can't even go down that far. That's bad. Like that, yeah. That's not great. And yet, at those depths, there's still life. It's because spoiled. Life finds a way. Well, there it is. So, Andrew, yeah, I think what are you saying? I think another thing that would be scary in both cases is the vast nothingness. Like, if you could survive that deep underwater in some kind of suit, which doesn't exist. I mean, we have submarines that can go down there that don't crush themselves. Now, imagine you expect darkness around you. You don't want to go see? You don't want to go look? I want to explore the darkness. The darkness is going to stay darkness unless you figure out what's there and expose the darkness. Darkness is! Darkness is! Now, darkness, the tables have turned. Do with them whatever you'd like. Andrew, we should go figure it out. We should go figure out what's up there. You know, you shouldn't sit there with bated breath being like, don't go in there. No, go figure it out, man. That's what spaceflight is all about. You want to explore the dark? Play Subnautica. No, I don't want to do that. I'll explore the darkness of space, thank you very much. Which is advanced darkness. Have you seen the Nautilus dives to the ironbound World War II wrecks? Yeah, I keep up with those, dude. I'm pumped that they found the Johnston. One of my favorite ships in World War II. I'm like super happy that they found that ship. That thing. They found the bow that was blown off. Yeah, but hey, whatever. They found it. That freaking thing, dude. With Captain Evans, man. Read about the Johnson. Okay, quick space news tangent. Read about that ship and read about Taffy 3. Holy crap. You want to hear the most, like, bad melon farmers to ever sail the seas. Those guys were absolutely insane. In a good way. The good kind. I'm trying to find the quote. Hang on. You know the story? Dude, Taffy 3, man. In 1944, the Battle of Samar. Unreal. Like, that's just, how is that possible? How did you not die? Well, they did, but how did you not die sooner? Hey, Baron, how you doing? So, Taffy 3 was like 3 destroyers. I'll give you the quick cliff notes. Taffy 3 was a task force in the Pacific Theater Wars. 3 U.S. destroyers. The Samuel B. Roberts, the Johnston, and I forget what the third one was, to be honest with you. And long story short, due to a kind of a little bit of a screw up, they encountered a Japanese battle fleet, and these 3 freaking destroyers ended up holding off this entire Japanese like task force. They ended up holding them off, and not only did they hold them off, they did significant damage too. Like the Johnston went toe to toe with the goddamn Yamato and survived somehow. Somehow it survived until later when it was sunk. Not by the Yamato, but the Yamato, the biggest, the battleship with the biggest guns ever made. This thing went toe to toe with it. The captain was like, frick you guys. Frick you. I don't care if you have a battleship. I got guns. All right. I'm going to shoot you too. My guns shoot faster than yours, pal. I'm serious. It is the wildest story ever. The captain was just like, battleship's over there. All right. Let's get near it. Okay. Is this the one that had the front fall off and made it back home? That was the USS New Orleans. The New Orleans had the front actually fall off. And they made it to a port. They made it to Australia, Hokie, by sailing the ship backwards, 1,600 nautical miles back to port to get it fixed. Because the front fell off, and if they sailed forward, it would have sank the ship. Animad, that's right. The Johnston got so close to some of these ships, they couldn't train their guns down to shoot at it. That's how close they got. And this little freaking destroyer, that and the Samuel Roberts, actually went right up to a battleship, was just like, I'm not scared of you. And they caused so much havoc with this Japanese fleet that they held them off. They eventually got sank, but crazy. It's a crazy story. Is there a movie? There should be a movie about Taffy 3. The Battle of Samar is ridiculous. Like, it's something out of a freaking movie. Like, okay, if they made it into a movie, no one would believe it. No one would be like, that didn't happen. No, that didn't happen. There's no way that happened. Dude, the captain of the Johnston, man, Ernest Evans is his name. Hang on, I'm looking. Second. Like, dude, read about it. I'll link it, you guys. Read about this damn thing. It is nuts. This story is bananas. The Laffy's up there too, Anderson, for sure. Where's Captain Evans here? There we go. This bad melon farmer, dude. When the ship got commissioned, dude, there's a quote that he said, and it's legendary, dude. It's such a badass freaking thing to say. I forget what he said, dude, but it was something along the lines of, look, I'm the captain of this ship, and I intend this to be a fighting ship. We will sail into harm's way, and if anybody has a problem with that, they can get the hell off right now. It's like, all right. Okay. All right, pal. So that's what. Okay, I'm sorry. I was unfamiliar with your game. You know, like. I know, Tessa. It's bananas, dude. Yeah, Melon Farmer was built different. He's like, yeah, I'm gonna sail right up to that battleship. Frick them. They won't be able to shoot at us if we get close. I said closer. Go as close as you can and engage those Star Destroyers at point blank range. At that close range, we won't last long to get those Star Destroyers. We'll last longer than we will against that Death Star. Literally that, but in real life. Yeah, literally that. That's what they did. You trying to die again in MSC or something else? I'm trying to play MSC, you butthole. Oh, Wolfin, there's the quote. This is going to be a fighting ship. I intend to go into harm's way. Anybody who doesn't want to go along had better get off right now. What a freaking G. It's the most gangster stuff I've ever heard. Part of that story is in the movie The Gallant Hours. Oh, cool. So when they found the Johnston caused that ship caused such big problems with the Japanese Navy that the Japanese were like, all right, we're killing these sons of guns right now. I'm freaking sick of their crap. And they went after the thing and they shelled the thing so hard that when they found it sank, it was in pieces. Like when they found it, they found it off the coast. Like, look, it's in pieces. It's not like the ship got blown in half. They were like, no, kill him. You know, still has the guns trained, baby. Badass, man. Holy crap. Yeah, read about Ernest Evans and the Johnston, man. Unbelievable. That and the Samuel B. Roberts. You want a good story? Holy crap. That ship, too. These crazy melon farmers, dude. Absolutely nuts. Pretty well preserved. Well, funny thing is, talking about pressure and depth and stuff, guys, the funny thing is that the ship, like, down there, at that depth, where these ships are in the Pacific, there's no oxygen. The water is not oxygenated. The pressure is too high for there to be like free oxygen around. So the ships that are down there are actually in good, like what's left of them are in remarkably good condition. Life can't grow down here. I mean, partially, like maybe some like small microbial things, right? But the ships are still they're like relatively intact, which is, I mean, with the exception of pieces of the Johnston's engine being on the ground, not inside of the ship. Yeah, I think that's its engine. I think. Yeah, there's a piece of it. That's an FCS. That's the fire control system, or what's left of it. There's another piece that looks like a turret barbette. Yeah, that's broken. It's not pressure based. It's just poor circulation, plenty of consumption, and no production. Oh, yeah, I knew I was saying it wrong. Thank you. It'll buff out. You know, it's I'm there. Yeah. That is a piece. You know it's bad when you can't tell what piece that is. Like that's not great. Actually, there's just while we're on a quick side tangent, the Lexington. They found the Lexington a number of years ago, and there's this crazy picture of all the planes. Like all the planes that fell off the ship when it sank. Check this out. Look at that. That plane is like 80 years old. Like what happened to the Prince of Wales. Yeah, there you go. And it's too deep for people to get to it. That's right. Last Stand of the Tin Can Sailors by James Hornifisher. Cool. Yeah. So when the carrier sank, all the stuff fell off of it. Like, dude, look, you could see the combat sorties that freaking plane ran. It ran 4 successful missions before it landed back on the carrier and sank with it. And look, there's a Felix the Cat graphic on it, man. Your favorite ship is BB-36. Nevada. The Nevada, dude. The Nevada's my favorite ship. Seriously, that's my favorite fighting ship from World War II. It's not even close. Yeah, not missions, kills. Excuse me. I said sorties. That's wrong. You're right. You're right. That's my favorite World War II ship. I've talked about it on stream before, dude. If the ships were intact, they would be on the surface. Well, actually, Andrew, it's funny you mentioned that. Ships like the Yorktown and stuff, the Yorktown just caught on fire. So structurally, the ship was intact, but they couldn't put out the fire and had to scuttle the ship instead. Fire is the enemy. Ask any sailor. Ask any Navy sailor or any sailor in general. Fire is bad. The ship sinking, you can fix that. Like, you can close doors and stuff, right? Fire, if you don't deal with the fire, you're screwed. You are screwed. Like, you're screwed. Like, that's worse. Rather take on water than fire. Like, so the Yorktown, for instance, it burned from the inside out. Like, it burned everything up in it, but the structure of the ship was there, and then they had to sink it. So the Yorktown's at the bottom of the ocean. It's relatively intact. It has no wire harness, but it's relatively intact. Can't float if it's liquid. Yeah, there you go. That's my favorite fighting ship from World War II, the Nevada. The Nevada is crazy. So I'll give you the quick cliff notes of this ship. It was built before the U.S. got into World War I. It served in World War I, shelling targets in Europe. Then it served through the interwar periods. It was at Pearl Harbor. It got bombed, got underway, sank in Pearl Harbor. They refloated the damn thing, and then they hot rodded the ship with an Iowa. I'm serious. This World War I battleship, right? They kept the main turrets, but they took all the modern fire control systems from an Iowa class and grafted it to this old ship from World War I. So look, see the double barrel 5-inch secondary battery, and all the fire control systems. So this thing was a resto modded battleship, right? And then after they fixed it, it shelled targets during D-Day. And then after D-Day, it shelled targets in the Pacific. It was at Iwo Jima. See? France, Iwo Jima, and Okinawa, and it was in Tokyo Bay for the Japanese surrender. The ship did freaking everything. And then the Navy wrote it off and slated it for target practice with a nuke. Twice. Yeah, they nuked it 2 times. The funny thing is that the ship was so damn well built, didn't sink. Dude, this thing got hit directly with 2 Fat Man bombs. So in 1946, the U.S. took the leftover atom bombs that it had from World War II because they wanted to keep making them. Then they wanted to bomb Japan until they surrendered, and they ended up surrendering, right? So they had extra. So they used them in a test. They used them for a test called Operation Crossroads. What they did was they towed all the ships that they didn't need anymore from World War II out to Kwajalein Atoll and then nuked them. If you like the environment, don't read about those. Don't read about those. So there was two tests. There was Able and Baker. The Nevada survived both of them. It wasn't like it was next to the nuke and got fire damage. They dropped this like next. Well, the Baker shot they didn't drop. The Able, they dropped it from a B-29 like what they'd been doing. And then the Baker shot, they sunk that nuke underground in the water, not underground. They sunk it in the water underneath a landing craft and detonated it to see what a nuclear depth charge would do. Yeah. Yeah. That's a lot of damage. You guys have seen the depth charge nuke before. Everybody's seen this footage. It's B-rolled all over the place. That's the Baker shot right there. It gave us SpongeBob. That's right. You see all the ships? The Nevada's in there somewhere. It's close to the epicenter. The crazy thing about Operation Crossroads, the Baker shot, guys, just on a quick side note. There's a picture of the target area here. Look. The Nevada, ship 32. Look, inside of the, like epicenter right here. The crazy thing about this is that they hit an aircraft carrier. They hit the USS Saratoga, dead center. And there's a famous shot of the explosion in Operation Crossroads from one of the atolls. Check this out. So see that right there? See this big black scorch mark right there? Turns out if you blow up a nuclear bomb underneath an aircraft carrier that's floating on top of it, when it blows up, it immediately vaporizes all the water, but the outward pressure is enough to push an aircraft carrier upright. That blast mark right there that looks like a skyscraper right here, that's the USS Saratoga with the aft of the ship planted on the seafloor and the bow of the ship pointing straight up. Nuclear depth charges can make ships do cartwheels. And the Saratoga was not a small aircraft carrier by any means. It's big by modern standards. The Wilson cloud lifts, revealing a vertical black cloud larger than the ships in the foreground. One popular but discounted theory claims this was the upended battleship Arkansas. In reality, the dark area is caused by the Arkansas's hull interfering with the development of the spray column. No, that's the aircraft carrier because they found the damn thing upside down. It's vertically integrated. Seriously, they found it like upside down with the aft part of the ship in the ground. I've never read that part before, dude. I've read plenty of things about the Saratoga doing a backflip. A backflip. Either way. Yeah, nuclear depth charges. But anyway, I'll have to read more about the Saratoga. I'm pretty sure that, whatever. There's plenty of stuff on the internet. Think someone would do that? Just go on the internet and tell lies? So the Nevada survived both of those. And they didn't know what the hell to do with it. They didn't know what to do with it. It survived 2 direct hits from a nuclear blast. And they were just like, what do we do with the ship? It's fine. But it's irradiated, so there's not much we can do with it. So actually, the first thing they tried was sending a bunch of guys onto the ship with mops. And trying to scrub the ship, the irradiated ship. Hey, it was 1946. They didn't know any better. Figured it out, though. That's not the way you want to figure that one out. So the Nevada, after that, dudes, they didn't know what to do with it, so they used it for target practice. It survived a bunch of salvos from the freaking from the Iowa. The USS Iowa kept hitting it, and they kept shooting it, and it wouldn't freaking sink. After she was thoroughly examined, Iowa and 2 other vessels used the Nevada as a practice gunnery target 65 miles south of Pearl Harbor on July 31st, 1948. The ships didn't sink it. It was giving a coup de grace with an aerial torpedo. They kept shooting it with 16-inch shells and it didn't do anything. It just stayed afloat. Anyway. It was reportedly so radioactive there that a captain who was concerned pulled a fish out of the water, put some film or something on it, and the fish took its own x-ray. Oy. So the Nevada was my favorite ship. That's my all-time favorite Baron. Me too. That's the best ship. That's the craziest ship during the war. It was that served in World War One. It shelled targets during World War One. It was at Pearl Harbor in World War Two. It was at D-Day in World War II. It was at Iwo Jima. It was at Okinawa. It was at Tokyo Bay. It was at the surrender of the Japanese in Tokyo Bay in 1945. It got nuked twice and it didn't sink. And then they shelled it with a battleship and it still didn't sink. And then they had to torpedo the sucker and then it finally sank. Dude, the thing is the Terminator of freaking warships. Anyway, guess where that ship was made? Fore River Shipyard, baby. Quincy, Massachusetts. Only a ship that stubborn would be made by New Englanders. That makes more sense now, doesn't it? The thing belonged in a museum. Yeah. Yeah, now the Nevada is a nuclear submarine. Yep, exactly. Only a ship that stubborn could be made by Bostonians. There's no way. There's no way that ship survives if it's made by, like, in San Francisco or New York or something. No way. They did find it. Yep. They should have installed a Starlink on it. I mean, have you visited BB59? Yeah. Wait, no. 59. Isn't that the... Yeah, that's the Massachusetts, right? Yeah, of course. Duh. Many times. Anyway, yeah, nuclear depth charges do work. Okie dokie. That was little things on Battleship. Let's get back to space stuff. So, we got an update here from Firefly. Let's see what they're up to. Today, progress isn't only for the nation state. It rests upon the shoulders of builders. A few days after our historic moon landing, Jason Carmen came by to capture the moment with our Ghost Riders. Check out a behind-the-scenes look at Blue Ghost Mission 1. Okay. Yes, I will. Thank you very much. Oh, it's 14 minutes. All right, cool. Let's roll.
10 years ago, a few ex-SpaceX engineers got together with a dream. They wanted to build a new company, not to compete with their former employer, but to do new things, like create smaller rockets and orbital service vehicles, and maybe even land on the moon. Well, just a few months ago, Firefly attempted to do just that.
Blue Ghost lander is a go for powered descent initiation.
And if they're successful, this will be the first time in history that a private company has landed on the moon.
1201 alarm. 1201 alarm. Set time for go flight.
A few months ago, we made a movie all about the future of space. And as we were getting ready to release it, one of our subjects was getting ready to launch a mission to the moon. I flew out to Austin, Texas to go behind the scenes of their mission to the moon. This building may not look like much, other than the giant rocket in the parking lot, but this building is where a moonlander was designed, built, and flown in just under 3 years by a new space company known as Firefly. But
I'll check
before
in
we
a
meet the
second,
team, let's take a look at the inside of the Blue Ghost lander. Firefly is normally known for making rockets, but a few years ago, NASA asked them to make something entirely different.
When you first see the lander, first thing you probably notice is the structure. So we have the aluminum face sheets, we have composite legs and struts that make up the rest of the structure. Propulsion system is one of the other noticeable things that pops out. You see 8 RCS engines. You look underneath, you see a big main engine sticking out from the bottom. There's communication systems, which are also extremely important. So our radios and antennas. You see all the different payloads that stick out. They all have their own unique form factors and come from different places.
Blue Ghost Mission 1 is our first lunar lander mission with the NASA CLPS office, so the Commercial Lunar Payload Services. Our job was to take 10 different NASA payloads to the lunar surface. We got this contract early 2021, and we've been working on it, design, build, testing, and operating it ever since.
I started before we had a clean room behind me. We didn't have a mock here. We had some hardware that was starting to come in, but really nothing that looked anything like a lander. So to be a part of the team, to go through the process of assembling everything in this clean room, going through all the different testing, we were really starting from scratch.
It's been our first spacecraft. We couldn't really leverage what we've already done at Firefly, but the wealth of knowledge that we have from history, from previous scientists, from the Apollo missions, the foot pads that we have on the lander, the lander mass to the foot pad diameter was taken as the same ratio that the Apollo missions had. And so there's a lot of that happening.
Go through this phase of designing, and then you spend a little over a year building it, and then another year you're just testing it constantly. We tested it in our clean room, and then we sent it to JPL and tested it more. So it's just this massive test campaign before ultimately sending it to Florida and integrating it on the fairing. I think I'll always remember the last day you saw it on Earth is it was mounted on the path in the SpaceX clean room, and the fairing sides are just kind of closing in on it, and you just kind of see the lander up at top before it got mounted to the launch vehicle.
We recently covered the design and mission iteration of the Apollo program, which isn't so different from some modern space programs today. All of these fast and modern engineering programs are taking advantage of something known as agile engineering. And the sponsor of this episode wants me to tell you all about it. Flow is the modern requirement.
Like everything that you have set up so far, is it gonna work? Is it gonna do its job flawlessly, or is there gonna need a little bit of a hand there to make everything work? For launch day, I was in charge of making sure that everything that needed to be working on the ground was working, and if not, solve it.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. And let's go.
I was in Florida. I watched the launch from the beach with my family, and it was a really personally rewarding moment, but it was also terrifying.
There's that call out. We've passed through Max Q.
Pairing separation confirmed.
Pretty cool. We watched this one, right? I'm pretty sure we watched this, guys.
Separation confirmed.
My worst nightmare was that we separated from the launch vehicle and never got signal.
Blue Ghost is drifting away from Falcon.
Oh yeah, I remember this. We did watch this.
There's kind of this uncertainty that happens between launching and then getting comms with your satellite, because there's a lot of different factors at play where you might get comms really quickly, or it might take a minute until you're in the right orientation, location, field of view for your ground stations. It's now time to lock in. They're all focused. They should start getting data very soon on those consoles.
Dude, I remember. I was like, I don't think they got a signal.
SSC has AOS. Stand by.
Oh.
That was AOS.
How about that?
How about that?
And I don't think I'll ever forget hearing our flight director in my ear just say that we had acquisition of signal.
That was amazing. We were imagining it was gonna be a little bit harder. We were gonna have to fight for it, but we were just sitting there, and then we said like AOS, and we had the signal. Everything in the control room became alive, and now it was like time to work. All the different console teams started just looking at their data and then just making sure that our lander was safe and it was starting their journey.
From all of us here at SpaceX, it has been a pleasure having you on board, Blue Ghost. Safe travels.
During our transit, we went around the Earth, and that helped us check out our communication system, make sure that we started getting comfortable with all the maneuvers that we were gonna do, so that when it came time to get to the actual lunar surface, we had already pretty good confidence that all of our systems were working.
That 45-day transit to the moon, we're doing several things like checking out the lander, the subsystems.
I remember the first time that we fired the engines in orbit. I think that was the first moment that a lot of us held our breath. Fluid system had never seen propellant before. You know, none of that had ever flown through the system. We tested the engines as an individual component, but we hadn't done it as a full system. And so you kind of see these graphs and, you know, you hit fuel and you just see them jump up. Everyone pauses, checks the data, and you're like, oh crap, like that went really well. So I think we kind of got a little more confident as we went through it.
All the burns that we did to get there gave us a lot of confidence also as a team, being able to execute to our procedures, be calm, be ready in case of any anomalies presented themselves. But really everything just went nominal. So our team just kept that confidence going all the way until the landing day.
With the launch and cislunar injection complete, 40 days passed, and then the world got to see clear footage from the moon for the first time in decades.
It's still good, man. That's still good. I've seen this footage before. I don't care. I don't care. I don't care.
Now it's time for the hard part.
It's so
Lunar
damn
landings
cool.
have always been a tricky affair, and Firefly was about to try one with no pilot on board.
1201 alarm.
1201 alarm.
1202.
Set type, we're go flight. OCOM, we're go for landing.
During the Apollo 11 landing, the onboard computer had a few errors, and the system relied on Buzz Aldrin to pilot and fly the spacecraft to the lunar surface. And previously, other landers have attempted to land on the moon's surface without success.
Another private moon landing, another mishap. Texas-based Intuitive Machines' latest lunar mission, the Athena lander, tipped onto its side, mirroring the company's first moon landing last year.
Fast forward
The first one was a little worse than that, but
to the day of the landing, you're seeing the clock timer count down and you get closer and closer, you start getting nervous.
also they said Buzz Aldrin took the controls. No, Neil Armstrong took the controls. If math serves me left, I've been wrong about a lot of things today. I'm pretty sure Neil flew that sucker down to the surface manually for the first time. Yeah, Rares. Dabble. Okay, you guys know. Yeah.
Way to
Buzz
calm down.
Aldrin
It's like,
didn't
okay,
fly that
just
thing.
think about it. It's another simulation. We got this. We've done this multiple times.
Really, that last 2 hours before landing, that the tone definitely changed in the mock. And
Is
there's
that
this
a
window of time between
moon stress
DOI
ball?
and PDI, that final power descent initiation, where if you're going to abort, if you're going to go around the moon another time, that's really your only opportunity to do so. Because once you command PDI, once you commit that descent, that's the point of no return. At that point, you're commanding it
look
and
at
you're
that
going.
picture!
No matter what, you will be making a landing attempt.
What
Starting
the?
with our power descent initiation, go no go pull, starting with payload,
Go.
comm,
Go.
ground
Dude, that's a
software,
real picture.
flight software,
Flight software.
Oh
AVI,
man.
AVI is go.
VNS,
VNS is go.
GNC,
Go.
FIDO,
Go.
prop,
Go.
TCS,
Go.
systems,
Go.
C,
Go.
FC.
Go.
All Gonzo's Blue Ghost landers are go for power descent initiation.
BDI.
50 meters up.
Dude.
30 seconds remaining in flight.
Like I said, dudes, I've seen this footage before. I don't
11
care. It's still
meters up.
cool. What the f... You've got to be shitting me.
Y'all stuck to landing.
Excuse me.
We're on the moon.
Sorry. My bad. I'll put the sensor beep in.
First commercial company in history to complete a fully successful moon landing.
Just a few days before Blue Ghost launched, we filmed with Bridget Oakes for our Frontier film, New Space. There was a clip from it that we didn't show.
Over decades of thinking about this, and every piece I put together to be a part of something like this with this team, it's finally here. And it's surreal. And I think if you shot me a text an hour after that, I'm not sure I'd have words.
It was right after landing. Hearing all of the systems were nominal. Everything was fine. I think the second we were not live on broadcast and it went to the mock, I fell apart. One of our marketing team members was standing right there. I got off, I pulled my headset off, I ran over, I gave him the biggest hug. I'm pretty sure he was just holding me because I had just collapsed. I think that's really when it truly hit, and I didn't realize how much it was going to hit and impact me until I think it was probably a minute after landing.
All consoles, let's proceed to surface operations.
Pretty good, man. Pretty good. Pretty good. It's pretty good.
It's been 4 days since we landed. The focus now has shifted from taking care of our baby, and now the focus is on the payloads.
The lunar surface mission is really what we were paid to execute. We have payloads on board that are getting their science data right now. We're drilling into the lunar surface. We've collected regolith samples. We've studied the EDS technology where they can repel lunar dust from a surface. All this is what they signed up for. And so continuing to get them more data through the lunar day and into the lunar night is what our goal is. And so we're just focused on system health and making sure that we're providing the best data for our teammates.
When we walk into work on Monday, I heard several people say it feels different. Like, it feels different to come into work today now being the first successful commercial company to land on the moon. Definitely changes the tone. It adds a level of seriousness and attention. You know, people really recognize Firefly now, not just as a launch vehicle provider, but as a spacecraft provider and as a lander provider. It's very apparent what we're capable of, and this is just the beginning of what we're going to do.
Outside of just engineering technical disciplines and what the next step is, having a reusable vehicle in 2026
MLB.
with larger capacity to lift and Elytra, another product line for in space, I think that's the biggest thing that we're looking forward to.
One of the crowning achievements of the 20th century was man landing on the moon. NASA went from not existing to developing the Saturn V rocket and Apollo spacecraft in just 11 years.
Dude, did you guys see that picture? That shot of the business end? The shot of the S1C? Pretty good shot. Then you notice the dude standing there working on the center engine. Remember how I said it was really hard to convey the scale of Saturn V if you haven't seen one up close? Well, that picture does it pretty well. Yeah, see the dude standing there? Dude, Saturn V is bigger than Starship, dude. It's wider. It's wider by about this much. It's a big piece of equipment, dude. Yeah, that picture conveys scale pretty well. Dude, she's a monster. I mean, Super Heavy is no slouch, dude. Don't get me wrong. But that thing is still pretty damn cool. Hey, he's got his harness on, cardiac. We're good, man.
Existing
It's
to
fine.
developing the Saturn V rocket and Apollo spacecraft in just 11 years. But today, progress isn't only for the nation state. It rests upon the shoulders of builders.
Firefly is building the road to the next frontier, one mission and one dream at a time. Tonight, we didn't just reach another mission milestone. Together, we created a moment in history. Blue Ghost's successful landing for commercial industry has a critical role in humanity's journey beyond Earth.
So ad astra per aspera, Firefly, and keep on building.
Who's that dude? Who's that dude? Because this is really good. Dude, wicked. That was really well produced, guys. I'm gonna, if you could, I'm gonna give that dude a follow. That's pretty rad, man. I'll post the socials anywhere. Go over and support that. That was a really well cut documentary. It's pretty good, man. Man, that was cool. Jason, if you ever saw this, I thought this was a Firefly internal video, not your entire video. So my fault for showing the whole thing. I feel bad because I usually ask before I do something like that. You can't know that's not just a tiny man in that Saturn V picture. What? Yeah, well, whatever. All right. Speaking of Firefly, let's see. They have another post here. Blue Ghost's lower deck is undergoing structural testing for Mission 2 to the moon. All right, let's go. Built with the same advanced carbon composites as our other launch vehicles, every component of our lunar lander is rigorously tested to endure the extreme conditions from launch all the way to lunar touchdown. Sad, what are you saying over there? Super Heavy's the kind of thing we should be doing today. People of the 60s made the next revolutionary technology. Now it's our time to do that. Innovation like Starship is what we need. You'll get no argument from me, man. 1152 in that video is something with grid fins.
It's been 4 days since we landed.
1229 is better.
When we walk into work on Monday,
I think that's a satellite, considering there's a second stage behind it. I think those are solar panels, man. Could be wrong. I mean, it's got Mylar wrap all over it, and that's a second stage behind it, if I'm looking at that correctly. Solar panels could be used as grid fins. Anything could be used as grid fins, if you're brave enough. Even you. So this is a load testing cell. See the hydraulic jacks right there? Load testing. Kind of similar to what we were doing with our super heavy stage in Kerbal before this space news. Similar idea, only ours involved a lot more explosives. But, you know, is mayonnaise an instrument? No, Patrick, mayonnaise is not an instrument. Horseradish is not an instrument either. Cool. Favorite that. All right, sweet. So that's what's going on in Firefly's world. Let's see what's going on in Relativity's world. We got another vidya. What are they up to? From design releases to hardware builds, engine qualification testing, and launch site development, June was a month of more meaningful progress across every part of the Terran R program. In this update, we highlight completion of the Stage 2 flight tank weldment. Weldment. That's your word of the day. Strong arm emoji. The build of a second stage vacuum development engine, now readying hot fire testing at Stennis. Fire emoji. Ongoing first stage engine qualification testing. Rocket emoji. Launch infrastructure progress at Cape Canaveral. And more. No emoji. All right, let's see what we got. God dang, the B-roll footage is going to kill me.
Terran R monthly update. Let's dive in and recap key milestones.
Let's dive in and make sure that our audio isn't underdriven.
12 component level critical design reviews, ranging from trays and manifolds to avionics components. We also released the flight design for the first stage engine, which unlocked flight engine production. The team has printed multiple batches of flight hardware for more than 40 unique parts for Terran R's first stage engines, including injectors, combustion chambers, and heat exchangers. On the stage manufacturing front, the team completed the second, third, and fourth circumferential friction stir welds, joining the second stage LOX dome to the LOX
Ooh, stir welder. Very nice.
barrel and the fuel barrel to the common dome and fuel dome. This completes the Stage 2 flight tank weldment.
Oh, that's nice. That's pretty good. That's pretty nice in there. I gotta sneeze. Turbo. It's a turbocharger. Why wouldn't you sneeze that way?
A huge milestone for the program. We set an ambitious goal to have a tank by June, and the team rallied to make it happen. All remaining welds on the Stage 2 downcomer have been completed, making it ready for structural.
Downcomer. All right. So, okay, you guys want to learn something cool? We were talking about during Kerbal, we were talking about vibrations and shock vibrations and jerk and stuff. That all kinds of things that make movement around, you know, make stuff move inside of the rocket. So take a look. Look at this downcomer. Interesting thing there. See the bellows right there? See the flexi joint? There you go. Vibration dampening right there. Or damping, not dampening. We're not soaking it in water. See it right there? See the flexi bit right there? That's designed to basically flex, allow a little bit of flex in the hose so it can move, or the downcomer so it can move around. That it helps you partially dampen vibration. Pretty cool, huh? Look at it. Yeah, it's a little baby downcomer. Yeah. You see that downcomer? This downcomer fits really nice on this welding table. That's pretty good, huh? You want to see SpaceX's downcomer? That's SpaceX's version. That's Super Heavy's version of that. I'm pretty sure that transfer tube is the size of Terran R. I'm pretty sure. Yeah, see, this is you versus the transfer tube she won't tell you about. Tells you not to worry about. That's what it is. Actually, it's a transfer header tank tube. I call it a tank tuber. And I'm going to call it tank tuber on Flame Trench tomorrow. And I'm going to piss Jack off. And it's going to be really funny, actually. And I'm going to keep calling it that.
Acceptance testing. Stage 1 transfer tube.
Super tuber. I like that. Dude. Super tuber. That's even better. Yuri, I like that one better. Can I borrow that? Can I borrow that? Super tuber. You have any idea how much fuel you were flowing? How much fuel you were flowing? 65? 63. Isn't the max flow rate 65? Yeah, it is. What exactly does it do? See if all of these tubes that we're looking at, not that one, but the tubes that we were looking at are fuel lines. Yeah, it's an internal fuel line for the vehicle.
Discovery, go at throttle.
Deadbringer, 2 to the 6th months, 64-month resub. Thanks, man. We'll need a poll. Yuri, super tubers. Yeah, Yuri. Okay, I have your permission. Yeah, I'm using that. Super tuber.
Coming welding. We've also welded development stringers with our newly installed horizontal friction stir welder, which will increase weld capacity and improve flow time for parts through the factory. This month, we finished building the second stage vacuum engine, which has since shipped to NASA status for testing. Manufacturing of the stub nozzle is underway, which will be used in ground testing in place of the full-length nozzle extension. This development article will be tested in our dual bay engine stand.
Wait. No. 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 Light it on fire. Oh, wait, they will when it fire the rocket. Don't light it on fire. Throw it in the trash.
Alongside the first stage qualification.
They blurred the branding on the tooling? Where?
Since shipped to NASA status for testing. Manufacturing of the stub nozzle is underway, which will be used in ground testing in place of the full-length nozzle extension. This development article will be tested in our dual bay engine stand alongside the first stage qualification engine.
You
first stage
melon
engine
farmers.
qualification continues to rapidly progress, and the team is over halfway done with the qualification campaign. We're rapidly completing ascent, re-entry, and landing objectives and demonstrating full run boxes. Back in Long Beach, shear towers for the structural test stand have been installed. These test fixtures will apply large shear forces to components, verifying that they can withstand the loads experienced during flight. Thrust structure and Stage 2 testing will begin on the stand later this year. New test stands are coming online too. Construction is underway on the Stage 2 downcomer test stand and static and dynamic test fixtures for the stage separation mechanism. At our launch site in Cape Canaveral, water tower piles have been installed, with foundation work coming up. Work on structures and supporting infrastructure, including cryogenic system fabrication, is ongoing.
Cool.
That wraps up a busy second quarter. Stay tuned for more progress in what is sure to be an action-packed 2025.
Relativity, man. They went quiet for a little while, but ever since they got a cash infusion from ex-Google executive Eric Schmidt, they've been starting to post stuff, dude. I always say, guys, talk is cheap in the spaceflight industry. But once you start showing some hardware like that, and that, and that, test stands, engines firing, crappy, stupid nozzles that shouldn't exist. Ooh. See? Especially flight hardware. Actually, that's... the guy said it himself. I don't... Well, actually, let me listen to it again, what he said about it. I think that's a mule engine. It's a test mule. Hold on.
This month, we finished building a second stage vacuum engine, which has since shipped to NASA status for testing. Manufacturing...
So... See all these extra lines and stuff? Usually when you see a rocket engine that looks like a Christmas tree like this, it's because it has a lot of sensors. Because one of the things that you have to do when you first fire a rocket engine, you usually have two sensors in line. Now, why? Why have two sensors? Well, in case one doesn't work, right? Right? That would be at face value. That would be okay, if one doesn't work, we have the other one. Because we don't know if it's going to work. But that's not necessarily what's going on. Usually, developmental flight rocket engines have two sensors on it that do the same thing that are two different types of sensors. So two pressure sensors or two pressure transducers. But one of those is a ground testing pressure transducer, and the other one is a flight, the one that's going to fly on the engine. Now, why? Okay, so you understand having two sensors. Why have two different types of sensors? Why would you do that? Well, you got to make sure with a sensor, a ground sensor, you got to make sure that your operational one works. And you got to verify it. So you use two different types of sensors. So the point that I'm trying to make to you is that a developmental engine is very easy to spot. It's very easy to see one because it has a bunch of extra smuts on it. It looks like a Christmas tree. Even SpaceX's early Raptor engines looked like this. Everybody, when they have it, because you need to verify that your sensors that are designed for flight, which are usually custom made, even if they're off the shelf or something, you have to verify that those are working. If you fly it with two of the same sensors and one of the sensors doesn't work and the other one works and it's the same thing, that could be a problem. So these sensors that are used on test mule engines are called developmental flight instrumentation sensors, or DFI sensors. At least that's what NASA calls them. I don't know. Everybody probably has their own name for them, as opposed to the OFI sensors, operational flight instrumentation sensors. So you'd usually have two sensors, twofold redundant, two sensors that are doing the same thing that are different designs. So you can verify if both of them are telling you the same thing, that they're both working, right? And you're actually, when you test a rocket engine, you actually test the sensors on the rocket engine too. That's part of the design, right? Pretty cool, huh? The developmental sensors also may be higher speed and higher resolution, more expensive sensors in case there's hiccups that lead to a funny. Yeah, they're hot. Yeah, exactly, man. Yep. Astra makes videos of their non-existent hardware. So yeah, in case you guys didn't know, like that's a test mule engine. See all the stuff that's up there? All the wires and all the extra plumbing lines. See these hard lines there are pressure lines. And see all the extra wiring that they have on it? That's a test mule. That motor is probably not going to fly. Although it might. I mean, you never know. You could just take all this stuff off and just plug all the holes like where the sensors were. But I find that if it was up to me, that I wouldn't test engines that way, because all the leftover parts where the sensors were, that's just another thing that can fail, right? Best part is no part, which is the other reason why you usually see developmental flight instrumentation engines or like a test mule engine that usually doesn't end up flying, because their design is different enough with the sensors that if you tried to refit it for flight, you'd have to build a whole new engine. So just build a whole new engine. I want to see you want to see the DFI sensor Christmas tree in some spaceflight company's office. Yeah, right. If you have an English and French sensor, you still can't get any usable data. What? Quite right, mate. Oui, monsieur. You could also leave them on for a first flight test. That's right, Spoiled. That would be a pathway as well, but still cool. Yeah. I like looking at these videos because people are just thinking like, oh, they're testing the rocket engine. That's great, but we know what to look for. I hate that a lot. I hate that a lot.
Go and throttle up.
Pop, 68-month resub. Thanks, man. Was that meant to be an Australian French accent? Yes, monsieur. There's always bosses and ports for access that are left out of the production designs. You got it, man. Yeah, Meatwad, I would suspect that jet engines are the same way. I know that jet engines have I know there's there's like a F-100 engine out there that got the trash beaten out of it on a test cell somewhere at an Air Force testing laboratory. I know that's a thing. they kick the snot out of those engines. We mate. You've seen it? Yeah. Oh yeah. Yep. Hang on, got a message. Give me one sec. Trey, I'll check your link in a moment. Cool. Trey, what's your picture? It's French Australian. Is that like French Canadian? No, my friend. No, my friend. I think I have Niall's links already. We're done with the relativity video, so hey Louis, what's up, dude? Do I have that? Do I have that? Do I have that? I don't. What is this one? Right? What do you want me to see here? Niall reposted Space Coast Live. Steel pieces are being delivered for the flame trench. Oh. Ding! Ah. Still here. Well, that's good. My Lando Billy D impression was great. All right. You got a lot of balls coming here after what you pulled. How you doing? Lando system. No, Lando's not a system. He's a man. Dude. Guys, this is, 39A is coming together real quick. The Starship pad at 39A. It's coming together fast. The thing is, man, is Pad B, they've pretty much got Pad B ready to go. And the thing about it is that, it's always going to take a constant, it's always going to take a certain amount of money to develop the pad, right? And if you build one, it's going to take a certain amount of money. But if you build a second one, it's not going to cost as much. The reason why is because the first time you go to put together something like a launch pad, right? First time you go to put it together, you don't really know how to put it together because you've never put one together. The second time you go to put one together, you know what to do because you learned from putting the first one together. So how this pertains to, seeing hardware being moved around for the 39A Starship pad is that I think it's reasonable to be able to extrapolate the turnaround time of construction for Pad B, because as far as we can tell, the pad at 39A is a copy of the second pad at Starbase. If you can reasonably extrapolate how long it took them to make that, right? I mean, this isn't really enough data to plot, time here. But I think it would be reasonable to assume that pad at 39A is going to get done quicker than everybody thinks it does. Why? Because they just built one in Boca Chica. Heck, they're still finishing it. So what do? You have the guys that made the flame trench for Pad B at Boca Chica and all the wall segments, the guys that put that all together, you just send them over to the Cape and have them build it there. Do the same thing that you did here, just do it over there. And then that justifies the development of the pad. The more of these pads that they build, the cheaper it's going to be every time you build a pad. That's why during the Apollo program, we built 3 mobile launchers for Saturn V, because if you could build one, you build 3, and it's not going to cost 3 times the price. And exactly, Aqualix. The price savings of making them in an assembly line can be significantly more than the price of shipping it. Yeah, there you go. Pretty crazy, right? All right, let's see what's up. We already did relativity. Let's see what we got a post from Rocket Lab. A lot of people have been telling me about this today. So there's a picture of Neutron landing on a not autonomous spaceport drone ship. What is Rocket Lab calling it? We've signed an agreement with Bollinger Shipyards, to complete the build-out of our 400-foot landing platform for Neutron missions that return to Earth at sea, expanding our development of Neutron recovery infrastructure to Louisiana. This is a render, Louis, but that rocket is in development. We've seen pieces of it. Wish that was the case for the Artemis Mobile Towers. Well, cardiac arrest, that's kind of where I'm going with that. I've often said, and we'll kind of dreading talking about this, I've often said that NASA needs an administrator that understands this. NASA needs a direction, and they need an administrator that understands this, that if you buy in bulk, the seemingly billion-dollar price tag of some of this stuff doesn't get really expensive. And you can improve your flight rate with higher cadence. Right? And if you improve your flight rate, you're improving reliability inadvertently, and you're driving costs down. Somebody at NASA didn't get that memo. We heard pieces of it. We did hear pieces of it. You're not wrong. Dabbledot, I don't know. We can talk about that more. I was kind of saving that for the end. But, yeah, we'll see. Jim tried really hard. Well, Rares, that's one of the reasons why I like Jim so much. He got it. He understood. He went to the SLS program and said the president needs this thing to launch sooner. You guys have been sitting here for a decade at the time. What the hell have you been doing this whole time? And they're like, well, we take the specs from the engineers and give them to the software people. And Jim was like, you physically take the specs from the engineers. Why don't they just do them themselves? Like he went into NASA in 2017 and said, what would you say you do here? Shut up, Mimsy. File TPS report. Thermal protection system reports. Well, Foz, apparently they haven't because their damn heat shield doesn't work. But that's cool. So, okay, little bit of a deep dive. This deep dive doesn't have to do with submarines or battleships. This deep dive has to do with rockets, but it's marine assets for rockets. So, that Neutron rocket is supposed to launch out of Wallops Island, Virginia, the Mid-Atlantic Regional Spaceport. So Mars is what it's called. It's right here near Chincoteague Island in Virginia. So now we know that there's a marine asset. So if you see where this construction is going on, see where this construction is going on right here, that's the launch pad, right? Hey, Arsenal, 97-month resub. I'm not sure I want to talk about that, Arsenal, but like I said, we're kind of saving it for last. So that's Neutron's pad right there. It's right next to Electron's pad and MLV/Intari. Well, was Intari's pad right there. Yeah, Wallops Island's turning into a multi-pad launch complex. Multi-orbital rocket launch complex, which is pretty sick. Sounds good, soldier. Just dropped in. Hey. Anyway. So, now I'm wondering. So if a Neutron launches from here and does a downrange landing, how do they get Neutron back? I'm actually asking. I'm genuinely curious here. How do you get Neutron back to the pad? So the factory where they make Neutron is actually over here. You could just see them starting to build it in this outdated picture. This picture is over a year old. I wonder if there's a newer one. Nope. That's the newest. So how do they get Neutron back here? Where's the heavy dock? Is there a dock near here? The closest one, my guess, would be Chincoteague. It would be up here. Hey, does that waterway go all the way to that intersection? This is the press site, Aqualex? That's the press site. There ain't no heavy dock here. I don't think that's dredged either. I'm pretty sure that's just natural. Could they build one? Oh yeah, Badojo, of course they could. But you would obviously... What the heck is the name of that place? Okay. Okay. So I'm trying to figure out where the damn dock would be. I don't think Wallops has a port. What's this? Ah, that's a training airstrip. Oh. It was called Butt a Woman before they changed it. What? Was it? Looks like there might be a dock here or something. But none of this looks dredged, and if it was dredged, it looks like it was dredged a long time ago. No, I'm kidding. Maybe they'll tow it up the creek or something. But yeah, there's no port here. I've been right here. I've stood right there. There's nothing there. I'm just wondering where they're building the dock. Because the factory is here where they're building Neutron. It's right there. And then the launch pad's over here. Wait, what's this? Oh, what do we have here? Wait, why were there retention ponds right here? There is a dock, and it's right next to Neutron's pad. But it looks like it hasn't been used in some time. Yeah, there was some type of dock here. See it? See this, those things where a ship can butt up against them. Maybe they'll fix that. It's definitely concrete. That's definitely concrete slabs. So move something heavy on it. I don't know, Louis. It's hard. Maybe AI would be the way to detect if AI is AI. What about on that waterway I pointed out earlier? I don't see nothing, dude. That seems like that would be the right spot, but yeah, I guess not. I also see go fast, turn left over here, and I'm wondering, does this dude just straight up have a racetrack in his backyard? You know, that's, you can do that? You just put a racetrack, put a dirt track in your backyard? The location I go to wherever there's a rocket launch from Wallops is called the old NASA ferry dock. That's on the other side of the dock that you were looking at, most likely. The old ferry dock, Hokey, is right here. You can tell because of the way it is. Oh. Interesting. Interesting. Hey, Lemon. That render looks like KSP with mods. Yep. Anyway, that's cool that Rocket Lab got a lead. They got a shipbuilder to build their drone ship. That's pretty cool. Neutron, I think, though, is still a little ways out. I'm pretty sure we're still a little ways out from that. Yeah, okay, there you go. So check this out. So this one's coming from NASA Sun and Space. Bring! Somebody gifted sub to Louis. This is the view from within the sun's atmosphere. NASA's Parker Solar Probe just released imagery from its closest ever flyby of the sun, revealing details in the solar atmosphere that scientists will be studying for years to come. Right.
Liftoff of the mighty Delta IV Heavy rocket with NASA's Parker Solar Probe.
Ever since NASA's Parker Solar Probe launched into space in 2018, it has been circling closer and closer to the sun and taking images along the way. In December 2024, it made its record-breaking closest approach to the sun.
500,000 miles an hour, if you're asking.
That's when it took these historic close-ups of the solar atmosphere, images that are changing the way we understand our star.
With images like these ones, we are actually going to have this full understanding of how the solar atmosphere works, and in particular, to try to predict the solar activity and mitigate its impacts.
The images were taken by the spacecraft's Wide Field Imager for Solar Probe, or WISPR, which observes space in visible light. WISPR doesn't look at the sun directly. Instead, it captures solar material just...
Who does? It was a joke. I know the answer to that question.
As it comes off of the sun. When it took these images, the spacecraft was only 3.8 million miles from the sun's surface. If Earth and the sun were 1 foot apart, Parker Solar Probe was about half an inch from the sun. At that distance, the spacecraft was immersed in the solar atmosphere known as the corona. Here, streams of electrically charged particles flow outward from the sun at over 1 million miles per hour, forming the solar wind that fills the entire solar system.
Cool.
These images reveal previously unseen details at the origin of the solar wind.
Dude, that's badass.
The amount of clarity and the amount of details that we got from Parker Solar Probe is totally unprecedented. But also we see
that's really cool, man.
Before, and that's where the fun begins.
If you look closely, you can see key features in the images. This is a collision of 3 large outbursts of solar material known as coronal mass ejections, or CMEs.
Yep.
The most impactful events, multiple events that are one following the others, and understanding that interaction between CMEs will help us also have another view of their potency for space weather.
That's cool. Lemon, how many cheeseburger lengths per second is it moving at? Asking for the Americans. Oh, I don't know. I couldn't tell you. I ate all of them. I ate them all. Sorry. Shouldn't use food as a measuring system with Americans around you. We'll just eat it. Sorry, man. I could give you the measurement in bowling alleys. Does that help?
When the most impactful eruptions reach Earth, they can trigger auroras.
Sorry.
They can also
I would measure
harm
it, but I ate it.
satellites, disrupt power grids, and expose astronauts to dangerous radiation. On the far left, there's another key feature. This region marks an important structure known as the heliospheric current sheet.
Hi, Louis.
If we zoom out and look at the sun from the side,
Bro.
the current sheet looks like a twirling skirt that extends out from the sun and across the
Whoa,
solar system.
hold up. Can I see that one more time? I knew about this. I knew about the heliospheric currents. I know that. That happens. What was this next thing?
If we zoom out and look at the sun from the side, the current sheet looks like a twirling skirt that extends out from the sun and across the solar system. This invisible current sheet is a boundary separating where the solar wind's magnetic field changes direction from north to south.
Are you kidding?
It surrounds the whole sun, and it never disappears. That's actually one of the regimes of the solar wind that we have to understand.
The current sheet is important to study because it can affect how impactful eruptions can be at Earth. We've never seen these phenomena.
So you could have negatively and positively charged solar winds? Cool. I didn't know that. That's really neat. I mean, that makes sense. Yeah, that makes sense to me. I didn't know that. I thought it just blew it out. It's like, oh, there it is. There's your wind. Yeah, electron heavier, electron poor plasma. That's freaking rad, man. Dude, we got to find a way to surf those waves, man. Bussard ramjets, let's go. It doesn't work like that, I know, but also.
In such detail before. And scientists are continuing to study these images to piece together how the sun affects Earth and the rest of the solar system.
Parker Solar Probe is opening our eyes on a new reality about our star, the sun. It is rewriting the textbooks for us.
Cool. That's pretty rad. See, now I'm wondering, like, dude, could you? And it has a magnetic field. Oh, that's all right. EJ's dumb theory based off of learning new information. If you have positive and negatively charged solar winds, you could make an ion thruster, right? You could make an ion thruster with an intake that intakes solar winds and uses that as part of your reaction mass, like a jet engine, like almost the Bussard ramjet, but not, but almost. I mean, it would only work really well when the closer you are to the sun, but because there's more sun there, but I mean, how would you get around the ripples, though? The positive and negative charge would really screw with you. Oh, Lemon, it's just a theory. I'm sure there's something wrong with my idea. Not enough mass, it's too diffuse. Well, collect it. Collect it into a tank of windage. Interesting. That's super cool, man. Parker Solar launched on Delta IV Heavy in 2018. I lied. I said I touched that Delta IV Heavy. I didn't touch it. I came about this close to it. Me and Das had the privilege of seeing that thing in the HIF, in the Delta horizontal integration facility before they put it out on the pad. Delta IV is pretty big. Actually, you know what? Hold on one second. I might be able to show you. Please hold. Where are you? Where are you? Give me 1 second. I'm just looking for something real quick. I don't think it's in there. Nope. 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 I'm just looking around. I might have that picture somewhere. Guess not. No, I guess not. Could have sworn I could have sworn I found that picture the other day. I was looking for something. Nope, it's gone. Anyway, next bit of news. So this next bit of news is coming from ULA. We heard earlier in the week that they stacked the Vulcan first stage for the SF-106 mission. Now we have pictures of them putting solid rocket boosters on the vehicle for the Space Force mission. Pretty cool. Send rocket pictures, please. Yeah, right. What's this mission? Space Force 106. I have no idea. It's classified. I don't know. But they are working on it. How many Vulcan launches have we had? We'd have 2. We had 2 of them. Right? There was Peregrine, and then there was CERT 2, which had an observation. And then and then this one. Yeah, that's it. You're going to assume that they're colonizing the sun when it's night then. Oh. Okay. All right. Okay, let's check this out. So I showed you guys this a little bit earlier, but SpaceX did stack the new transfer tube for the Block 3 Super Heavy. This is the methane transfer line that also acts as a header tank. It's the fuel line, but it's also the tank that they use for atmospheric restarts, for air starting the engines. And it does not actually go in the square hole. It goes in the circle hole. See that? So there's a hole down there at the bottom. This is the bottom of the methane tank right here. This thing actually goes through that. And this piece up here where the baffling is, right? Or not baffling. See where the flexi joints are? If you notice, this thing has flexi joints right at the front. If you were watching the stream earlier and you saw us look at Relativity, right? Relativity had a flexi joint like that on their downcomer, but their downcomer was about the same diameter as that pin right there. Super Heavy's downcomer and header tank and transfer tube or whatever is the size of a Falcon 9 first stage. No joke. Oh, no, Super Tuber. That's what it's called. Super Tuber. Thank you, Yuri. Is this the tube version of one more lane? Just one more lane, bro? Yeah, no, just one more tube, bro. It'll be fine, bro. No, Raiden, to be 100% honest with you, I think SpaceX has... So, what's the right way to say this? The right way to say this is that stainless steel is forcing SpaceX to make things in ways that we're not used to seeing. Like in this particular scenario, they took the transfer tube and the header tank and they made it into one thing. But it's also, you could tell also from all this stuff that's attached to the side that this will be used for tank baffling as well, inside and out. So you kill 3 birds with 1 stone. You make your header tank, you make your transfer tube, and you make tank baffles. Because let's be real, super heavy has to baffle. Inside of rocket fuel tanks, guys, there's baffling, right? And that's to make sure that the propellants don't slosh around. Super heavy really has to deal with this a lot. Because think about it. The engines are still firing. The thing does a freaking flip, right? And then it comes back down and it has to steer and then it has to get caught by the chopsticks. Let's be real. The propellants are sloshing around in that thing a lot more than a regular rocket, right? A lot more. So this is a very mass efficient way of making baffling, transfer tubes, and header tanks, and making sure that you don't slosh propellants around during landing, because that's looks like that's what happened to 15. 15 had cavitation and it blew up when they tried to do that emergency landing maneuver. The emergency landing maneuver was planned, believe it or not. So, yeah, what's the diameter of the tube? 3.6 meters, Kelly. It is the size of a Falcon 9. That's the size of a Falcon 9 first stage, dude. Can you believe that? Huh, that's baffling. Oh, I bet. No, it's transfer tube. Oh, jeez. Yeah, see? That's funny. But yeah, that's what's going on with Starbase here. What other stuff do we got? They did that yesterday, and it's actually kind of crazy that SpaceX posted about it. They usually don't give us updates like that, but that's still cool. So, Niall has an update here. What's he saying? Wait, why am I freaking followed the dude already? What the hell? It keeps unfollowing Niall for some reason. Apologies for the low quality. We only got screen grabs from the stream this time around and not the actual document itself, but we did get a visual render from Highway 4 what the air separator will look like. So SpaceX is working on building an air separation unit. Air separation units they're looking on building this north of the pad. So here, let's leave Wallops for a second. So will the LOX tank be longer? So Raiden, my guess is that the cylindric part of the methane tank is actually going to be shorter and the liquid oxygen tank will be longer. That's my guess, right? Because you're displacing a ton of liquid oxygen with that gigantic transfer line. So I would move the common dome up 4 or 5 rings to make the methane tank, the main methane tank, smaller and make the now toroidal liquid oxygen tank longer. So that air separator is right here. This is an outdated picture. There's now a roundabout right there, and you can see the roundabout in that picture, right? So SpaceX is working on an air separator. An air separator is what you'd use to make liquid oxygen. Which is pretty cool. When you go back down, will you do circles and then a roundabout? Yeah, probably. Doesn't actually unfollow, it just randomly says it does. Oh, that's weird. It did it again. Hold on. Whatever. Whatever. Take a look. What's that, Mutter? Oh, the Crew 11 thing. Yeah, I'll post that in there. Why is Massachusetts trending? I don't care. Interesting. So can an air separator make methane or just oxygen and nitrogen? Well, there's not much. I mean, I was going to say there's not much carbon in our atmosphere, but there is. But there's not a lot, but there kind of is. But where would you be getting the hydrogen from? You know, with an air separator, you're separating, you know, nitrogen and oxygen, and then maybe a little bit of CO2 in there as well. That's enough. That's enough to have nitrogen. It's enough to make liquid oxygen for sure. But yeah, you're missing some components to make methane. Get hydrogen from water. I mean, you're next to salt water, that you could do that way. But yeah, this air separator, as far as I can tell from that design right there, you got a couple of vaporizers, and a nitrogen tank. That tells me that this is just for nitrogen and oxygen. That's what that's telling me. At least for now. SpaceX might go crazy with it someday. You don't know. If you do it in a humid area, you can split water. I mean, Boca Chica is humid, but the thing about Boca Chica is not humid all the time. So, who knows? I mean, I'm not saying that they wouldn't. That doesn't look like they're going to have like all English, man. This looks like they're not going to do all that just yet. Oh, this seems to have changed. The plan seems to have changed. They moved some stuff around. I think that's what Niall was talking about. They are building other stuff, guys. This RGV original thing doesn't have the road that's going over here. Also, there in Texas, methane just comes out of the ground for cheap. That's true. Interesting. Interesting. Pipeline to the new LNG facility. It's possible. Yeah, that's the other thing, fellas. SpaceX could make their own quantities here, but to be honest with you, if they got approval to make a pipeline over here, you see this construction site? There's a liquefied natural gas terminal going in Brownsville, at the port of Brownsville here. This thing, that construction project is nuts. I've been down there and I've seen it. There's probably like 40 or 50 Liebherr 11,000s working on this job site right now. Like, this is an old picture. See all the cranes? They're everywhere. So if they have an LNG terminal, that means a pipeline comes to here from somewhere in the oil fields north of here, right? And it wouldn't take much to just extend it over to Starbase over there and, you know, basically have an infinite fuel supply, infinite fuel glitch. You make that with the air separator, you could have as much, how much fuel do you want? All of it. But they want to do a Sabatier reaction on Mars, so they might as well build a small electrolyzer plus air separator set up to test it. It might be, dude. I'm saying, I mean, you could, dude, they own the land. Starbase is like They own the land and they own the city. Like, they're the local town and the property owner, dude. They can do whatever. The environmental review to put it through the estuary, though. Yeah, who knows? It's crazy. This looks like somebody playing City Skylines. Isn't that nuts? I mean, look at it. It looks like City Skylines. It looks like you just zoned a big residential block right there. I mean, they basically did. SpaceX also is building a lot of houses over here. Yeah, dude. If we could see an updated picture of this, there would be a huge, like, town right here. And this picture's from last year. This picture's from April of 2024. Here. Actually, I'm pretty sure RGV has a shot of the town from the other day. Yeah, there you go. Look. What the frick, dude? The houses will get abandoned and the residents will complain about noise pollution. They didn't check the noise pollution tab. Pretty sure this is all employee housing, dude, but yeah, that's a funny joke. It's hard to think about how cheap land was down there 10 years ago. Yep. This is employee housing for me. Levittown in real life. Yeah, I know. Pretty crazy. Pretty crazy. All right. Okay. Mary still lives there, yes. So, the president posted the other day that he is pleased to announce that I'm directing our great Secretary of Transportation, Sean Duffy, to be an interim administrator of NASA. Sean is doing a tremendous job on handling the country's transportation affairs, including revamping ATC, while at the same time rebuilding roads and bridges. He will be a fantastic leader of the ever more important space agency, even if only for a short period of time. So, I went and looked around, guys. Now, I could see a lot of you in both chats saying, "Oh, what a great idea." I didn't really know too much about Sean Duffy, and I know what you guys are expecting. You're expecting me to say, like, "Oh, I didn't know that he..." Dude, okay. I don't know anything about the dude. I've read his resume, like, in his a couple biographies, like I was reading them last night. The guy has, like, zero aerospace experience. Like, zero experience with anything that has to do with planes, spacecraft, whatever. The guy has a economics degree, I think. I think he's an economics degree and he's a lawyer. Right, so he's got a law degree. So, like, and he was also on The Real World Boston in the late 90s on MTV. So he's also a reality TV star, interestingly enough. I mean, the guy has a pretty lengthy track record being a district attorney. So that's kind of cool. But as far as I can tell, like, I don't. Okay. I'm not looking for people to just crap on Sean Duffy all the time. That's not what I'm like. What my next question is about. Like, okay, the guy's the Secretary of Transportation, and as far as I can tell, he's been doing a decent job, I guess. Like, I know he's been doing a decent job because politicians that do a good job are the ones you don't hear about. That's my general rule of thumb. I don't know too much about this dude, but I don't. I mean, he's only the interim administrator of NASA, but like, dude has no space flight experience, like nothing. So, he is only temporary, and acting NASA administrators don't like. With that all being said, like, the guy doesn't seem to have much experience. Like, he doesn't even seem to have much experience with transportation, which is like, why did you make this person Secretary of Transportation? Why did we do this? But whatever. I mean, that's something I don't really know too much about, right? However, you know, for the people that say, oh, great, this guy has no spaceflight experience, that's not that big of a deal. The interim NASA administrator is basically just keeping the ship on an even keel, and that's about it. So I don't think necessarily anybody needs to worry about like him screwing anything up. Like, I don't think he will, pretty sure. But also at the same time, like, why did this is a quick and easy thing to do. Why don't you just make NASA a priority for a change and select an administrator? Oh wait, you had a good one and you didn't do that. And once again, I'm not exactly sure how you run NASA and the Department of Transportation at the same time, but who knows? In my field, temporary more often than not means permanent. What are the chances he stays in the long term? I don't think he'll stay in the long term. I think they're going to find another person, and we'll have another NASA administrator by the end of the year. Problem is, vetting a NASA administrator takes time. You have to vet them. They have to go through a bunch of confirmation meetings and hearings and stuff, and it takes time. I mean, Jared took 6 months, and they got about a day from the confirmation, and then he pulled the plug on it, which I think, as that history comes more into focus, and keep in mind that was pretty still recent, I really think that was a catastrophically bad misstep for NASA. Yeah, that was that probably will not age well in the history of NASA. Yeah. It probably won't work that well. Yeah. With the budget cuts to NASA, would the administrator even have anything to do? I don't know, Nader. Yeah, NASA actually with the kind of appointing of Sean Duffy to be the interim administrator, I believe that like 2,000 NASA employees are going to leave. I think that's happening because of their buyout or early retirement, if I'm remembering correctly. I actually don't know for sure if that's because of him. I think it's just going to happen because it was going to happen, right? Because that's what they did at the beginning of this presidential term. They were like, if you want to leave, we'll buy out your contract, or you can take early retirement or whatever. Sorry, bro. I'm so blackpilled on it with how NASA is being beat down. Dude. Hey, Vargon, what's going on? Nader, I think it's easy to be like, this is stupid, whatever, right? But, you know, I'll play angel's advocate, not devil's advocate. You guys are already there. You know? Dude, anytime that NASA gets trimmed like this, I kind of look back to see if there's any real, like, historical precedents for, like, a shrinking of NASA's workforce, right? Now, good news and bad news. The bad news is that every time NASA's workforce gets cut, we arguably lose some capability. But that capability like, NASA has ways of being reborn, if that makes any sense. Like, the biggest historical precedent would be the Apollo program getting axed, right? That was a huge reduction in labor. And, well, you know, we did get the space shuttle out of it, which was cool. You know, it obviously wasn't the Apollo program, but NASA, I've noticed, is kind of resilient in this matter. You know, don't think of this as kind of defunding. Think of it as like reshuffling. Like, NASA's reinventing itself. Like the NASA from 1981 is not NASA from 1969. Now, one could argue that that's for the worst, but I would call that a lateral shift. Well, maybe a lateral and a little ways downwards. So if I had to guess, NASA will do something in the future, but it's going to probably be another lateral shift to something else. I mean, the plus side of this, dude, is that you know, with the House, what is it, HR1, with the big bill passing, right? That did give NASA's human exploration operations actually a pretty substantial funding boost, but it was at the behest of science, which is just, how about we just fund both? You know, we can do that, or don't, whatever. But yeah, NASA will most likely take a lateral shift more than anything. But you got to think about it. Like, this is not, it's not like when Apollo was getting canceled, dude. Does that make sense? It's not the same. And somebody already said it. It's already said it in chat. You know, we have this bustling commercial market. So in the same way that the NASA 1981 is not the NASA from 1969, their kind of job changed, and that NASA kind of pivoting away from gigantic human exploration operations programs like that ended up bolstering our science budget and getting us the crazy awesome science missions that we got in the 80s and the 90s, even even into the 70s, like Voyager, for instance, right? So, like I said, NASA's pivoting, they're shifting. Now, like I said, it won't, I don't think NASA's going wholesale by any means. Hayabusa. Guy blew out the mic, you hear that? That scared the crap out of me. I thought my computer crashed. Yeah, but this is the opposite. So, that was pretty loud. Yeah, that scared the crap out of me. So, I guess what I'm trying to say, dude, is NASA usually, historically, it hasn't gone under. They're not going to get rid of it. You know, and Congress won't get rid of it either. But, you know, they're gutting the science budget, increasing the budget for human explorations, just like when the Apollo program ended, they cut the human explorations budget and bolstered the science budget, and we got awesome stuff out of it. I think NASA still has some fight into it. I don't think this is the end. Historical precedent here means that NASA isn't, you know, kind of states that NASA isn't really going anywhere. Just what their job is going to change. And okay, here's the screwed up part. Here's the screwed up part. Now, do I think this? No, not necessarily. But it's possible that NASA, a lot of folks have said that NASA should be an agency that procures commercial stuff and goes and goes from there, and shouldn't build their rockets in-house. Now, I've always said that that's a stupid idea, you know, but maybe NASA's role changes in spaceflight as the commercial market gets more viable and as it gets bigger. I personally think that NASA's rockets are used for different purposes than something like what Starship is going to be used for, or what Falcon 9 is going to be used for. Don't get me wrong. In terms of all of Falcon 9's missions, there obviously is overlap with what NASA needs, but what's the majority of Falcon 9 launches that have launched? They're Starlink missions, they're commercial missions de facto, right? How many of the 500 and change Falcon 9 launches were NASA launches and NASA payloads? You know what I mean? So there is an overlap between a commercial rocket in this proverbial Venn diagram. There is an overlap for sure. But that doesn't necessarily mean that, you know, NASA should be procuring commercial off the shelf for every single thing. I think that's a very bad idea, personally. Would you say that NASA is flipping between human exploration and science? I think that would be a very astute thing to say, Lemon, especially given the fact that, you know, we think we're in a space race with China all of a sudden, which, you know, some could argue that we are. That budget, the way that NASA's budget was proposed, was sent through the big beautiful bill, right, kind of corroborates that. That's what I mean. NASA could, dude, it's possible, guys, and I know it's hard to say right now, but it's, you know, it's darkest before the dawn. You know, you don't know when the sun's going to come up if you don't have a clock, right? We can't predict the future here. It's possible that NASA could be in line for, maybe they're not going to take a backseat to commercial. It's possible that NASA could get back to doing Apollo style stuff. It's possible. I mean, look, they bolstered funding for SLS, and we got Artemis 4 and Artemis 5 on the books. That's a huge deal for SLS. That's good stuff. That, like, I get it. You know, people are gonna say, "Oh no, it's, you know, that's a waste of money or whatever." People are still gonna be tooting that freaking horn. NASA could land somebody on the moon. They did land somebody on the moon 50 plus years ago, and people said it was a waste of money then. So people are always going to say it's a waste of money. Whatever. Let's, you know, but like I said, it could flip. Just like it flipped at the end of the Apollo program. Maybe in the future, NASA goes back to doing crazy Apollo style stuff with human exploration. It's possible. I know that seems far-fetched right now, but it is a possibility. It's viable, for sure. I'm just concerned it's a small ball effect with science being cut, plus the timeline. Well, you could sit here and say that canceling Apollo was devastating for human exploration, and that's absolutely right. But you know, a scientific phoenix rose from the ashes of that, right? This does also, it's also a thing to mention that, you know, NASA can do both of those things at the same time. But who knows? If they give funding to the EUS, I haven't checked the details of the bill. I only saw the cliff notes for it, mate, because I was on vacation when it came out. I'd still have to read it. But yeah, I would assume probably yes. EJ helps me from dooming about space. Remember, DOS, it's easy to doom about space. I've been a spaceflight fan for a long time. There's some people that watch the stream that have been a spaceflight fan for 5 times the amount that I have. And it's easy to be doom and gloom, man. I won't take that crap. Because at the end of the day, spaceflight is a matter of willpower. If we're all going to sit here and we're all going to be doom and gloom about spaceflight, well, you know, not that our opinions really matter too much, right? But if we put that positivity out and we put that can-do attitude out, I don't know, maybe the right person hears it. It's so easy to be doom and gloom about stuff nowadays. I refuse to do it. Because you know, there was a while where, you know, with like, you know, when Viper got canceled and when, you know, Chandra got defunded and when there were huge layoffs at JPL and the orange guy wasn't even in the White House when that happened. There were times where it pissed me off. I'm not going to let it piss me off anymore. That's easy. That's easy to lose your cool when it comes to this stuff. That's the easy thing to do. I'm not doing that. Yeah, yes, but it's stranded humans in Leo for 50 years. Well, yeah, Hellfish, but the point is that people think NASA's done. They're not. It's a lateral shift, lateral slightly backwards, most likely, which is not the best thing, but bolstering funding for Artemis 4 and 5 could lead to a block buy. It's possible. that could be done if Orange Man decides to decides to have some concern for the freaking space flight program instead of just making it an afterthought for the Secretary of Transportation. It's possible that could happen, but that's only going to happen if the right person whispers in his ear, like maybe that person watches the stream. I don't freaking know. Probably not, but I'm not going to put negativity out into the aether. I'm not doing that anymore. I'm done with that. It's possible. Hey, Fred, 25-month reset. Thank you. Yeah, no problem. It's easy to get pissed off, guys. It's easy to get pissed off. Spaceflight's hard, man. It's a hard thing to do. And everybody, I know that everybody says that. Everybody throws that around every time something blows up in your face, right? And it's not that they're wrong. It's just what they don't tell you is that spaceflight's difficult. Stuff will fail. How you deal with it is how we're going to discern people from that complete missions and people that don't. Do you know what I mean? And do you think a negative attitude is going to get you anywhere? Hell no, it's not. Absolutely not. If the Apollo engineers went in saying, no, this is a stupid idea, there's no way this is going to work, guess what? Neil and Buzz would be dead on the surface of the moon right now. You can't think like that. And especially when it comes to space flight. You have to be on your game. You can't let it screw with you. I don't know. Maybe I'm wrong. Maybe it's the end. Who knows? Whatever. Guys, you know what? Even if it's the end of NASA, and NASA becomes some crappy regulatory body, right? We've got SpaceX, baby. We have a hustling and bustling commercial market. I've always said the best way forward would be for NASA to have a gigantic human exploration program like the Apollo program, and SpaceX being hell-bent for leather for going to Mars. Having both of those things at the same time is the most sustainable way forward. Is that likely? I don't know. Hard to say. I'd say it's less likely as of right now, but it doesn't mean it wouldn't happen. But I've also said what most likely is going to happen is that the commercial program is going to eclipse NASA, and then Congress it'll become increasingly difficult for Congress to find a need for NASA at all, which I don't agree with. I think that's stupid. And thankfully, I know people, I can hear you typing through the computer about your thoughts about the Big Beautiful Bill. Big Beautiful Bill did bolster some programs. It bolstered human exploration. So maybe that won't happen. It's possible. Maybe this isn't the end for NASA. Maybe it's just where our ideas about it are changing, which is possible. Like I said, it has happened in the past. NASA's goals have changed. Whether you like that or not, I don't know. I don't know. They're still going to do cool stuff. I wouldn't be too upset about it. I mean, losing all that scientific research will come back to bite us, to be very sure. Just like stopping the Apollo program will come back to bite us, But even if it all goes to crap, we have a hustling and bustling commercial market. Look at all the commercial stuff that I just showed you. People are building re-entry, Intuitive's building re-entry vehicles, Firefly's building lunar landers and new rockets. Relativity's cooking up something. SpaceX is going ham with Starbase. Stoke is working on their new pad. If the commercial market is what's going to carry us to the stars, so be it. I don't care as long as we go. I've offered the most sustainable way forward, but if that doesn't happen, I would not hedge my bets against commercial space right now. That will still get us out into the stars. It's just not going to be the most sustainable way forward. Not sure if you've covered this, but there's something working its way through the Senate now to restore a lot of that science funding. I mean, Dino, that's very much the other thing that I've said. There's no way that budget is going to stick. No congressman is going to have their NASA center in their district gutted. That's just at the absolute bottom scenario, that's less tax dollars for them. But, in the ideal world, that's pretty crappy representation of your constituents. It probably won't stick. Is that Titan?
Take your bear. Go see daddy.
He's like, nah.
Nah. Nah.
He's like, nah, I don't want to do that.
Um.
Hey, Bree.
Hi.
Bree's here.
Did you say you're booked until midnight tonight?
Yeah, pretty much.
No White Lotus? I cry. Alright, that's all.
Tomorrow, maybe. Don't do that to me.
What? Yeah.
Oh, I want to play Summer Car. Said I would play Summer Car, so I'll play Summer Car for a little while.
Oh.
And then I have the
That's not even a launch, right? Video games.
Get out of my office. Go.
What?
Get.
I love you?
I love you too.
Our lives to fight.
Get out of my office. That's bull crap. That's some bull crap. Did you see that? That's some bull crap, dude. Back. I gotta go to the bathroom, Daddy. Have you seen the Spitter discourse about Orbex? I haven't seen it, Doss. All right. Plus, this is ignoring everything that China's doing. Like I said, Lemon, bolster like a crazy expansion of NASA's human exploration operations could happen. Because, you know, politicians are kind of like, you know, but us as spaceflight fans know that China is they're going to the moon. And while I've said that it's probably going to take some time because you need a pretty complicated architecture no matter how you get to the moon, you could do it really two ways. You could do it by using a smaller rocket and launching it a lot and building something in space that's going to get you there, or you could go Saturn V style and build one big rocket that gets you everything there all at once. Either way, both of those architectures are very complicated. Earth orbit rendezvous, so the small rocket solution, that requires a much more complicated mission. While building a big Saturn V style rocket requires a much more complicated vehicle. Does that make sense? No matter how China is going to do it, I think they're going to do EOR from what I've seen. That's a complicated mission. That's really hard to do. If they're going to do EOR, so be it. It's still going to be some time. But once again, you and I could tell that it's on the horizon. They're not going to not go. That's stupid. Why would they just be like, nah, the Americans aren't doing it. Whatever, we're not going to. Yeah, does that sound like China to you? No, absolutely not. They're going to go to prove that they can do it by themselves. Right? Like just for the same reasons that we did 50 years ago, right? I get it. Once the politicians kind of figure this out, they haven't been able to put it together. They're close, they're getting there, but once they figure it out, that could lead to a huge expansion of NASA's human exploration operations. It's possible. That's what I mean. It's possible. It's possible. That is not a scenario that's out of the realm of reality. You know what I mean? I don't know, he saw the left half of the video. Well, yeah, it's not just about one politician figuring it out. Personally, well, that guy needs to figure it out. Just saying, maybe he will. You cover a Chinese moon landing on stream. I don't think they'd stream it, Rem. But if they did, maybe. Sure. That guy will not. Well, I mean, David, that's an easy thing to say. If you don't like him, you don't know. I mean, the guy has a pretty good track record with his priorities for NASA with appointing Jim. So I would say objectively that at least he is somewhat keenly aware of it, like somewhat acutely aware of it. Don't you think? Just putting it out there. You don't nominate Jim Bridenstine to be NASA administrator and not know much about NASA. Am I right? China moon landing will be filmed in the Nevada desert, just like the U.S. one. That's the Gobi Desert. Differences, but, you know. Kasanko. You're speaking Finnish because you want me to play Summer Car. Yeah, I get it. He posts, commercials amazing and I love it, but I want an independent agency too. I love capitalism, but I want a nonprofit motive organization doing space as well. I think personally that's better for scientific research, Nader. And that's what I mean about there's overlap between the rockets that NASA needs and the rockets that a commercial industry needs. But those are two different rockets. SLS ain't Starship. Those are two different things. You know, that's like saying you have a mail van and a go-kart and saying they're like, oh, they're the exact same thing because they both got 4 wheels. Like, no. That's, dude, here's one for you. I got another analogy teed up. That's like saying a Harrier and an F-16 are the same thing because they both fly. Nope. Try again. But somehow, in the public kind of zeitgeist, we kind of conflate them together. Oh, they're both rockets. They both do the same thing. No, they don't. They absolutely don't. They're different tools for different jobs. Jim is on the books? No. I was talking about the president's first term, Steve Kraken. I don't know. But, dude, maybe. It's possible. You don't know. It's possible. Like, that could happen. Dude, if he came out of the blue and said, I want Jim back, I'd be like, please do that. I mean, I don't know if it's going to happen or not, but who knows? Yeah, Alex, I know. It's disgusting. We're getting our lunch fed to us. It's gross and I don't like it. It's gross and I don't like it, dude. But, you know, part of the reason why I'm trying to be optimistic about things, not trying, I am being optimistic about things. Part of the reason why is because, dude, we didn't look at the Soviets in the 60s. Americans didn't look at the damn Soviets putting Yuri Gagarin in space, April 12th, 1961. 61. We didn't look at that and say, oh crap, we're screwed. Because that was a similar thing. There was a similar scenario. Soviets out of the blue, they put Sputnik into space on an R-7 Semyorka. And then they put Yuri into space. And then they put Kamarov into space. And he did his EVA. And they were wiping the floor with us. And then Khrushchev was going off saying, we're the future. Right? Do you think we sat there and said, oh, yeah, we're screwed? No, absolutely not. They were eating our lunch on the spaceflight front, but we certainly finished that frigging race. We'll do it again. I'm not going to sit here and pretend like, you know, it's like stuff isn't like kind of a little messed up. But we're not going to sit here and just take the L. Screw that. I'm not doing that. Game's changed, man. And that's what I mean about NASA's priorities changing. I'm not going to sit here and take an L. Screw that. We're not doing that. Oh, it wasn't Kamarov, it was Leonov. Excuse me. Leonov did the first EVA. Kamarov had his spaceship EVA around him. Respect, man. Yeah. Wasn't great. But like I said, we could sit here and we could say, oh, we're screwed. They're going to do it. They're the successors. We left all of our research. You know why we left the research open out in the 60s? Because that's what we do. We fail publicly. We put it out in the open. That's what this organization is about. We don't cover it up when shit goes wrong. All right? That's disgusting behavior. We don't do that. That's not what NASA does. So you could sit there and you could take our papers from 50, 60 years ago, whatever, and say like, oh, you're the successors. But guess what? You're never going to get to that point where you're just putting information out of the open. You guys don't do that. You guys don't even stream your launches. All right. You don't stream your launches. Everything's on replay. Why? What are you afraid of? Afraid of something going wrong? That's weird. Why would you be afraid of that if you're the spiritual successors? Curious behavior. Deadbringer, you might not want to take the L, but you are not the ones in the Rule 8 positions of power. NASA's funding is directly tied to public perception, and I influence public perception in that regard, Deadbringer. You want to win? You want to get the W for the West? Guess what? It starts in hearts and minds first. We did the Apollo program because we saw we needed to do it, and because we wanted to do it, and because we got challenged by the president. You got to want to do it again. It's public perception, man. Budget is directly tied to it. Whether you want to make any argument or not, you can do them all you want. It's true. Dan, it's all good, man. Large portion of our population seems to have lost our drive for exploration and discovery. Engineering. I don't know why or how to fix it, but it's sad to see. Hater, I've been on the front lines here for a decade, changing people's minds about it. The best thing that you guys can do is do what I do with other people. I'm not taking the L. I'm not doing that. I'm not going to admit that, I am a stubborn boulder in a river of crap that's draining out of, into Lake Pooperthon or something. I don't know. Come up with your own damn analogy, But it starts with public perception, man. That's huge. We got to get the word out. I'm sorry. I know it's easy for you guys to be like, EJ, you've gone off. You're crazy. Yeah, a little bit. You have to be crazy to like space. You have to be crazy to do space flight stuff, of course. Yeah, Rem, once again, lazy. That's a lazy ass opinion. I'm sorry, man. I don't mean to call you out. You're saying it's hard to sway public perception when SNAP and Medicare is going away. We did the Apollo program during the Vietnam War. So try again. Nah, I don't buy that. Sorry, guys. I feel very strongly about this. I don't know if you could tell. Anyway, see, a major noob, you're saying it's not the same anymore. United behind a cause then, and we had leaders in positions that were determined not to lose and understood the importance of scientific advancement. It made people understand that. Same mentality doesn't exist anymore. Do you think that mentality just came out of the aether? Just came out of nowhere? You don't think there were critics of the space program that were saying that exact same thing 50 years ago, dude? Dude, I don't buy that. I'm sorry. Dude, one thing I do know, man, is that if we're just gonna sit here and say, oh, it's not the same, we're not the same, it's not the same, guess what? You're definitely gonna lose. We're definitely not gonna do it if we think like that. I've seen, dude, I ain't no stranger to public perception of the space program. I've seen it over the last 10 years, everybody being huge on science and everything. I've seen that slowly kind of, people's priorities are elsewhere. I blame this thing, first of all. But that's another story. I've seen it happen, but we don't. If we're gonna sit here and just write it off as something that's gonna happen anyway, you know, of course that's gonna happen. You know, you don't take a shot on the goal, yeah, you're not gonna score a goal. It's easy. It's easy to say that right now. That's the easy thing to say. And the whole kind of crux of the spaceflight program is not doing things because they're easy. It's doing things because they're difficult, right? Because they're hard, right? I choose to have a positive opinion on this, and I will not be swayed. And I know that seems kind of weird. I get it. You're like, okay, man, have fun with that. Because it's easy to have a negative opinion right now. That's really easy. It's really easy to just say that NASA's screwed. We're screwed. That's easy.
This is space.
I'm not
I'm in
doing
space.
that. No way, man. That's an easy opinion to have. I'm sick of that. I'm sick of having the careful, easy opinions about things that have to do with space. That's bull. That's not the mentality that got us to the moon. I still think China beating the U.S. in the current space race back to the moon would be the best thing to happen. I think that's kind of what I was talking about a little bit before. It's possible. There is a very, very, very good chance that that could happen. Like I said, NASA's job could it's a possibility. It could revert back to the NASA of the 1960s, which is to prove that we can go anywhere we want because we're us. You know what, man? Like, it is an unlikely scenario, but it could happen. And if it does happen, I'll welcome it. It's possible, dude. It's possible. You know? Repost. Hell, maybe I should stream 2 and focus on aviation and do my part. I'm actually considering it in my brain right now. If I do, I may give you up for advice if that's all right. That's fine. Sure. I'll tell you everything I know. As Winston Churchill once said, the U.S. will eventually do the right thing after trying everything else first. That is us, isn't it? You'd think we'd learn, but whatever. Americans, we're stubborn. What do you want? It's just how we are. Pretty sure the U.S. wasn't $36 trillion in debt in the 1960s. Our entire monetary system was completely different in the 1960s than it is now. We were still on the gold standard in the 60s. Okay? Debt is not correlated to funding a space program correctly at the federal level. Case in point, we've been funding a space program for the last 50 years. What would I do if I was NASA administrator? David, you might not like this answer. I would do what the president tells me to do. Because if you want to stay as your NASA administrator, you do what he says. However, that wouldn't be without me trying to sell some key points. Thoughts on the 2,000 NASA employees resigning? Draco, that was going to happen because of the buyouts and the early retirement that the administration offered at the beginning of the term. Beginning of the presidential term. It sucks, but dudes, people are going to hate me for saying this. Hey, Flip, could NASA become a governing regulation body like the FAA? I would not want that because that means bureaucrats are running NASA and not engineers, Flipper. I think that's a really bad idea. And the National Science Foundation has written papers about this exact phenomenon happening, which is why NASA needs to launch more rockets, not less. Yeah, Jared, that's the other thing. So, guys, I see a lot of people in the press talking about those 2,000 employees that are leaving NASA and how NASA's getting gutted and how NASA's screwed. Okay, all right. This is what I mean about being truthful. I'm not going to sugarcoat things. NASA has a problem, or, well, it's had a problem up until now. problem is that there's people there that don't do anything. They just sit there and collect a paycheck. You know, scientists and engineers from past programs that aren't doing science and engineering, they're just sitting there at a job at NASA because their program ended, or they got defunded or something, or they switched to administration duties, or they're consulting for stuff. NASA has an aging workforce, guys. And as much as you're going to see the press spin that 2,000 layoffs into something bad, probably to try and slander the president or something, wouldn't be anything new. Certainly, he's not above criticism by any means, right? Nobody is. You know, that's the whole beauty of the West. You can say what you want and not have repercussions for it. However, a lot of those 2,000 people that are leaving NASA are retirees. They're early retirements. There are people that are sitting there doing nothing, taking retirement. And forcing people into early retirement is bad, generally. That is a bad thing. I want to be very clear on this. But also at the same time, NASA has an aging workforce. Young kids don't want to go work there. They want to work at SpaceX. They want to work in the commercial industry. Anywhere but. This is going to sound so screwed, and I would never wish this on anybody, but NASA, and the way I would have done this was to get these people back engineering things and have them teaching younger people how to do it, right? Which that's the ideal scenario. But the aging workforce at NASA leaving is not necessarily a bad thing. I'm sorry, it's not. NASA needs young blood, dudes. That's so freaking important. And that starts with having a program that people want to work for. You think kids want to go work for Artemis? If you were an aerospace engineer and you had a job working on SLS or a job working on Starship, which one would you take? See what I'm saying? It would be better to put them to work, but short of that, well, Bob, exactly. That's what I mean. It's not ideal. That's what I'm trying to tell you. But it's possible that good things come of this. I mean, a lot of people had asked me, like, what would I do as NASA administrator if I had, like, full control over NASA? I would go in there and I'd fire a lot of people. We've talked about this. I'd go into OMB and NASA headquarters and be like, frick all you. Get out of here. You guys suck. Leave. You know? Like, I'm not gonna lie to you. Yeah, Homer Hickam, a lot of ex-NASA alumni agree with me on that. Passing on industry knowledge is super important. Yeah, like I said, 2,000 people leaving is not ideal. I would never, if I was running NASA, I would never put it in. I would never put NASA into I would fight tooth and nail to never put NASA into that scenario ever, despite what the president said or didn't say or whatever. You know what I mean? But also, 2,000 people leaving might not be a bad thing, dudes. It's possible. If NASA breaks out and starts being real, if the executive chooses a real serious goal and NASA has breakout funding and they get a new program, right? People left and right are going to go work in there. You know? It's possible, dudes. That's what I mean. NASA's down right now, but they ain't out. It's possible. If they let NASA get back to doing NASA things, you know, and have NASA get in the game of like iterative design and stuff, because that's what they're supposed to do. They're supposed to do science and research. They're supposed to be blowing stuff up. That's the whole point. Not with people on board. If they let the reins go on NASA, it's possible. And I think it sucks because I think Jared Isaacman was going to do that, but anyway. Why are you flip-flopping? Flip-flopping. You think me offering both positive and negative scenarios with a hint of optimism over both of them is flip-flopping. That's what you got out of that? Really? All right, I'm going to stop. Okay. Flip-flopping. All right, go back to Twitter 187, please. Please go back to Twitter. All right. I'm going to go play Summer Car, dudes. I hope you enjoyed this space news. I'll see you guys in a couple minutes. I got to get the racing rig set up. So there will be a loss of signal on YouTube for about 5 minutes. On Twitch, you'll just see the title card for a second, and I'll see you guys back here in a moment. Thank you for watching. Be back in a minute.